Hey, what's up, y'all? Let's get this started. Let me share my screen. There you go. Start by just tweeting about this. Boom. There we go. Did I misspell in the description? Probably. Let's see. Can I still change that? I go here. Let me dump this in over here. Before I get a limp of coal. Ugh. Not for kids. There we go. All fixed. All right. Well, we'll just chill out here for a little bit till we hit our starting time, and then I'll jump into it. Let me maybe bring up, if I jump to GitHub. So we'll be using the starter here that I have on the screen. So this is something we did earlier this month for NX. Just to have a really nice way of people being able to, set things up for TypeScript for Advent of Code. So looking forward to seeing how it works here in practice. Hopefully it's helpful. I feel like it will be. Get that a little bigger. It's been a while since I streamed last and shared my screen. There we go. All right. Well, let me go ahead and get started. I think all I need to know is I need to run tests this way by adding tests to the target name. We'll just do like day 1A. I think there's watch. There's a test data flag. And I think that's pretty much all we'll need. So awesome. Let's get to it. So I already did the first part of day 1, so I've got my 1 star. Oops. That was weird. Whole computer just froze up for a second there. But yeah, got my 1 star. Let's go back to day 1 and get into... I'll kill my camera here so y'all can see all the prompts and stuff. So I gotta do part 2. I think part 2 for day 1, we're going to use the same data set. And so our answer for the question is 45,000. So I'm going to copy that. We'll drop it in here for day 2. And make that a little bit bigger. For our data, I think we can bring all of our This just reuses the same data sets. So I'll just grab all the data from part A and put it into part B. Should be good. So I'll go ahead and run npx nx test day 1b, hit a watch there. So it should fail the first time. Yeah, so we got 0. We expected 45,000. All right. So we had that. We'll make this smaller. Hit A on that. Oh, that's going to run all of my tests. Let's try that again. There you go. Alrighty, so for B. So I think we pretty much need to do what we did in part A, which was like get the total that each elf is carrying. Then we're going to get the top 3. All right. Oops. Shouldn't be too bad. So let's do this. We'll get our stuff from day A. Guess we need the get some. Oh, not async, export, get some. So we'll say turn into array of number arrays, and then we'll say sums, sums.map, get some, import that from the other day. Let's actually we'll say this is top 3. And we'll filter. Actually, I guess we need to sort this first. A, B. Oh, that's helpful. Copilot. That was nice. I think that does it. All right, and then we'll just do top 3, reduce, get some, I think. 0. Does it not like that? Oh, I see. We'll say cur. Not that bad. Plus current. Hey, he's passing the test. That's all we needed. So we'll go ahead and get rid of our watch, and we can get rid of test, and this should give us our answer for day 1B. There we go. Oh, interesting. It's going to output our answer there too. Oh, so we'll get this, dump it in here, hit submit. Hey, 1 star down. Let's go. Let's go day 2. What's going on? So the elves begin to set up camp on the beach. It's already in progress. Oh, rock, paper, scissors. Okay. An encrypted strategy guide, our input. Okay. So A is for rock, B is for paper, C is for scissors. Okay. What should you play in response? X for rock, Y for paper, Z for scissors. Winning every time would be suspicious, so the responses have been carefully chosen. The winner of the whole tournament is the player with the highest score. Your total score is the sum of your scores for each round. The score for a single round is the score for the shape you selected. 1, 2, or 3, plus the score for the outcome of the round. 0 if you lost, 3 if the round was a draw, and 6 if you won. Okay. Since you can't be sure if the elf is trying to help you or trick you, you should calculate the score you would get if you were to follow the strategy guide. This strategy guide predicts and recommends the following. Your opponent will choose rock, and you should choose paper. Okay. Total score of 16. Okay, so we can go back to our code here. And let's go into day 2A. So the answer they said was 15. Let's dump into day 2A test. So this will be just this right here. Paste. And we'll get our puzzle input. I don't think this is that hard. It's just going to be cumbersome. Paste. All right, so we'll do this again. We'll say test day 2A. Add the watch there. So we should get 0. Yep. It's saying 15. All right. So if we go to day 2, ATS, okay. So we got to figure out a way to parse out our data. So what did it say over here? Let's get, I guess, just some constants to start. I'm guessing we'll probably need these for day 2 as well. Const draw score 3. Win score is 6. Sport const. So this was really, I guess there was numbers for each one of the different symbols too. So rock. What was rock? 1 for rock, 2 for paper, 3 for scissors. Okay. For rock, 2 for paper, 3 for scissors. Okay. And I guess we really need to get a way to parse these things out too. So let's just have a function down here. Parse input. So this comes to, whoops, string array. And we really, this should be like our move, their move, and we'll have a type here. Choice, rock, paper, scissors. Our move is a, oh, let me make that capital up there. Go, their move is a choice. There should be an array of those things. So I think we want to split. Let's take our input and map it. So each one of these is a string. And we're going to take our input string. Say, yeah, it looks relatively right, but we need to get out of that. Guess what it is. So let's see what the order was. So A, so the first one's our choice. If it's A, it's rock. So let's say our input, their input, and then say constant our move, their move is map it. That looks about right. So we'll say case R, or I guess this was actually, no, case A or case X, was it? Oh, your opponent will choose A. I see. So we have to reverse that anyways. But it's A and wait, what was it? X is rock, Y is paper, Z is scissors. Okay. A or X. B or Y was paper, and then C or Z was scissors. And I need to switch this up because their input always comes first. It doesn't like this at all. I think it's just because I need to do as const here because it just thinks these are strings. Oh, and we're not returning anything yet. But yeah, now we should be able to return our move, their move. Switch. Oh, gotta do that on the inside of that brace. Void array. Okay. Oh, yes. Hey, there we go. Love it when they all just go away like that. All right, so now we should be able to parse out our input. So we'll say constant moves, parse the input of the data. Just console log that, make sure it looks about right. Okay, still got the 0 there, but we should see, okay, paper, rock. So now we should just be able to turn each one of these combinations of moves to points, and that should be it. So if we win, we get 6, and we also get points for the shape we selected. Okay. So let's say, let's grab this right here. Call this a move. Type move equals paste. Replace this with the move array. And we'll say function get score. Move is a move. This should return a number. So, yeah, constant our move, their move. Let's just destructure that out of the input. And so we'll say let score equals 0. I guess we'll just do if our move equals rock, score plus equals 1. So if our move is paper, score plus equals 2. That's if score plus equals 3. And then looks like GitHub Copilot did most of the work for us. If they're equal, we get that. Otherwise, yeah, I mean, that looks right. return. So instead of return here, it should be score plus equals. And I guess we need breaks after all these now. Same here. And then we should return the score. And now, score equals moves. Yeah. Yeah, Copilot gets it. We return the score. Okay, we're passing the test. So let's run this now against day 2A. Get rid of our test. All right, let's see if that worked. Hey, 2 stars for tonight. Let's go. Let's see. Cool. Let's go on to part 2. I feel like we're going to have misunderstood what we were supposed to do in part 1. That's what these ones tend to be. The elfish is helping with the tent and sneaks back over to you. Oh, the second X means you need to lose. Y means you need to end the round in a draw, and Z means you need to win. Okay. Total score is still calculated in the same way, but now we just need to take exactly what we did there, but we're going to change the way we get our move, I think. Okay. So we'll go back here. Same thing as last time. We're just going to dump this all into here, right? Nope, that is their actual data. Drop it in there, be in the test. Nope. There you go. There we go. And day 2B spec. What did it say, 12? We want to get 12. So we'll go ahead and do test day 2A watch. I'm just, instead of exporting all this stuff, I'm actually just going to like grab it all and dump it in, copy paste it over. I think we just, like I said, I think we just need to change this one function to change how we parse the input. It's like I'm just going to bake just how we get our moves into the parse function. So let's do that. Probably pasted too much. Yeah, just copy this, dump it up here. We can get rid of day 2A. Delete. All right. Oh, still testing in the wrong day. Day 2B. So this should fail because we should be getting 15. Yeah, but it wants 12. All right, let's hide that for now until we're ready. But I think it's just a matter of parsing this. So it should be case A, case B, case C. So this should be how we get the first one. So we'll just say const their move equals. Do I turn this into a giant turn area? I think so. Switch their input equals A rock. Otherwise, their input. Oh, we already got that. Okay, that looks right. Thank you, Copilot. This is making it much nicer, I feel like. Now let's get rid of some of these windows. There you go. Focus in. So that's their move. Now our move should be easy to figure out because of that. So I wonder, we probably need to do like a map of some kind. So it should be something that looks like move map equals, well, this is going to be a record of rock, paper. Oh, we had a name for that type, right? That was just choice, I think. Record of choice to a record of X or Y or Z to a choice. Cool. So for rock, we should have, what was X? X is we should lose. It's so confusing. Okay, X means you need to lose. Okay, so if it's X, if we need to lose, they've chosen rock, so we need to choose paper. Y is tying, right? Y, okay. You know, I bet there's probably actually a better way to do this thinking about it. Because yeah, we definitely don't need to go as far deep into it as I'm doing, but I've already started down this road. So I'm going to stick with it. But I'm pretty sure paper we need to lose, so that needs to be rock. I'm pretty sure we could have just parsed out the inputs and like we don't even need to care about what. Oh, I guess maybe we do. Maybe we do. Yeah, I think we do actually need to do all this stuff out. But yeah, Z means we win, so that needs to be scissors. And then for scissors, we should have X should be, we need to lose, so that should be paper. Y. Copa is really getting these wrong. And then Z rock. Okay. Oh, it doesn't like this still. Oh, because we're still not returning. So we should just return our move is that, and then we should return here our move, their move. There we go. Parse input. I think they said the scoring was the same. Let's see if that's, hit a save there. Let's see if that's passing the test. Yep, passed the test. So I'll go kill this, get rid of the watch, get rid of the test. See if that works. Answer. Dump it in. That's not right. Oh, it's too low. Okay. Well, we got our, let's see. Let's make sure our input's all checking out. That's not right, but I think that was day one. Maybe I should have named these differently when we made these things, but okay. Our answer was too low. But let's try when we do test day 2B. Huh. Looks like we're passing the test, but we're not passing the actual one. Day 2B. test data. Answer is 12. That should be right. Wonder if maybe there's a place I had my my code a bit wrong. So X, let's verify. Turn to day 2. You need to end in a draw. Second round, you'll choose paper, and you need to choose rock. Okay. Let me try, I'll just try getting the input again and see if we get the same answer. Still get your puzzle. Yeah, they said it hasn't changed. So that's weird. Day 2B. Paste. Wait, what is this? Day 2B, data day 2B. If we run it against it, 12. Was that the same I had done the first time? Let's see if I go back. Yeah, it's the same answer. So there's a bug somewhere in our code that our test case is not able to catch. That's fun. I guess we could debug it. Just to see what's going on. I guess there may be a simpler way of doing it too. Like, we really just need to know our move, their move. So our move map. So if they guessed rock, we should guess, this looks all right. Paper, rock, scissors. Yep. Their move and our input. I guess we could try making another test here, just because we're not able to get it. If we look at our test data, is there anything else that changed for part 2? Part 2. How the round needs to end. X means you need to lose. Y means you need to end the round in a draw. Z means you need to win. Let's debug through it and make sure our stuff matches. So it should be 4 and 1 and 7. Let's make sure that's right. Oops. There we go. Computer froze up again there. So let's hit the debug. And we'll hit oops. We'll hit a breakpoint. I guess let's do this. We'll say scores equals that. And we'll say const score And let's just set a breakpoint right here. See how that works. So we should have 4, 1, and 7. 4, 1, and 7. So that's exactly right. I wonder. There may be a bug hiding somewhere else in our code that's just not getting exercised by our test case. I guess this is a problem with running with Copilot. I've blindly trusted it too much. Let's see. Rock, paper, scissors. That should all be the same. Let me just verify that's right. Be weird if that was not the case, though. Okay. Their move is A. It should be rock. They choose B. It should be paper. Yep. I guess let's take a look at I guess we should still be able to see it. Our move is rock. Oh, our move is always rock? Is that right? Let's see. Go back to the test. So parsing it in, their move is rock because they chose A, and we need to tie. So, yeah. For their move is paper, we needed to lose, so we chose rock. Right. And then they chose scissors, and we needed to win. So yeah, that should be right. I guess let's try this. I'm just gonna hit play here, just because I want to go through and debug here again. So I want to try a. Let's do like this. Don't even care about the answer being right, because clearly that's not helping us. AX, AY, AZ. And then we'll do the same thing twice. And these ones will be B's. And these ones will be C's. And then let's try running this in debug and just see what's going on with moves. Okay. Their move was rock, 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 because it was A. Our move was paper to lose, rock to tie, and scissors to win. Then their move was paper, paper, paper. We should lose the first time. So we lost with rock, we tied with paper, and we won with scissors. And then their move was scissors, scissors, scissors. We lost with paper, we tied with scissors, and yeah, and we won with rock. That should be correct. Let's see what's going on if we hit the play. Here. So I don't know what this should be, actually. Well, 0, we should have lost. But we should have chosen rock. So we should have only gotten 1. Maybe there's something messed up. There's something screwy with the way we're getting our scores. That just happened to work right the first couple times. Yeah, because that one should be 1. The second one should be 4. The third one should be 7, right? How odd. Wait, no. Maybe I'm wrong. So the first one, oh, okay, we chose paper. So that should be 2 plus 0. So it should be 2. Yeah, okay. It should be 2, and then that one should be 1. Oh, 1 plus the draw. So I guess that's 4. So that one's right. The second one's right. The one at index 1. Then this one should be 6 because we win, plus what did we choose? So they chose rock, and that means we must have chose paper. So we should have gotten 2 for that. So this should be 8. So these are like switched. There must be something wrong here then. So rock, we get 1 point. Paper, we get 2. And scissors, we get 3. I think here should just have returned the score. Let's do this. We'll say return score plus so if we choose rock and they chose scissors, we should win. If we chose paper, oh, and they chose, this is what was wrong. Okay, we found it. If we chose paper, then paper beats rock. And if we chose scissors, scissors beats paper. All right, let's try that. Kill that. Oh, that's not what we want. Yeah. Let's try it there. That's significantly less than what I expected. Right. Let's run day 2B. Just run this in debug. Okay, moves. Okay, so scores. Oh, okay. Yeah, that's definitely wrong. Lame. That must be what's wrong. Okay. Kill that. Let's run this one again. Frustrated with that. I still got the same answer? That's not right, is it? Day 2B. Let's see here. I guess we'll go back to the debug. Let's debug on this. And check out the scores. Yeah, it's the same. we chose rock and they chose scissors, we should get the winning score. Otherwise, we should get 0. So the first move, we chose paper, and we won. Oh, is that what's wrong? Yeah, we chose paper and we won. We should have lost because it was X. If they chose, so that was, their move was rock. Their move was rock. There we go. We should have lost. Okay. Scissors. Paper. Oh man, I got all kind of twisted up here. Paper. They chose paper and we need to lose. We need to choose rock. We need to choose paper and we need to win. We choose that. They chose scissors and we need to lose. Choose paper. Okay. Let's try that. See if that gives us a different answer. This bizarre. Okay. That looks promising. Let's give it a shot. Hey! All right. Day 3, here we go. One elf has an important job of loading all of the rucksacks. What's this link? Oh no, the backpack problem. Lame. With supplies. Unfortunately, that elf didn't quite follow the packing instructions. So a few items will now need to be rearranged. Each rucksack has 2 large compartments. All items of a given type are meant to go into exactly one of the 2 compartments. The elf that did the packing failed to follow this rule for exactly 1 item per rucksack. The elves have made a list of all the items currently in each rucksack, but they need your help finding the errors. Every item type is identified by a single lowercase or uppercase letter. Okay. The list of items for each rucksack is given as characters all on a single line. A given rucksack always has the same number of items in each of its 2 compartments. So the first half of the characters represents items in the first compartment, while the second half represent the items in the second. So they split them in half. The only item type that appears in both compartments is B. Oh, okay. Hash mapping, got it. Second rucksacks contains that and that, so it's just split in half, and the only type that includes is L. V. Oh, what is this nonsense? Okay. Oof, oof, oof. Okay. So we just have a list of priorities here. We got to figure out the one item that is in both compartments and then get the sum of each of those based on their score. So let's grab this. This will be our test input. Oop, wrong way. Day 3A. Oops. Day 3A. Test. Paste. and day 3 a spec. So this is going to be 157. Save. Let's go ahead and start that watching. 31A. So get 0 the first time. Yep. All right, let's clear out a lot of this stuff. So we really don't need it. We just need to be focused on solving the problem. So I think it's going to be like a similar flow to this. We'll have like a function to parse the input. This is a string array, split, so rucksack, first compartment is a string. Second compartment is a string. And so we'll return a rucksack array. So we'll say return input map, split it. It's actually gonna be like slice 0 and like input string dot length. So like divided by 2 plus 1 or something. I think it's good. Yeah, I think it's gonna be divided by 2 plus 1. Oh, you slice the thing on a string? I guess so. Yeah. And slice like that. I think. Let's see how that looks actually. X parse input data. And let's just console.log our rucksacks to see what that's looking like. Is that right? First compartment. Nope. Went too far. One too far. I guess I didn't need the plus 1. Off by 1 errors. Yep. Let's see. So, yes, and HCS. Okay, looks like we're splitting it correctly. Then, like for each rucksack, we're going to have to find the unique function, find shared item for a rucksack. So rucksack. Turn string. I guess I could do like a union type with all the possible ones, but yeah. Let's see. So we'll say constant first. I don't like the way that solution looks. Let's do like this. First compartment, second compartment. We'll say constant first compartment map equals first compartment. Will that give us what we want? Ack item equals true. I don't know if splitting like that is right. I guess we'll find out. And then we'll say, we don't really need a map for the second one. We'll just say for constant item of second compartment, throw new error, no matches. Right? So now we should be able to constant shared items. Let's just log that. Shared items. Let's see if that matches. Lowercase p, l, p, vts. Yeah, that looks right. All right, now the last piece is to just do the mapping. There's probably like some string way of doing it, but I think I'm betting that Copilot's going to be able to help me out here. So I'm going to say constant score map equals A is 1, B is 2. Is that right? Lowercase is all. Oh, I'm going to hate writing all this out. Where's the scores? Did I skip over that? Oh, yeah. Okay, yep. C, D, E. Is there a faster way to do this with Copilot? I know it knows where we're going. I guess we're just going to keep doing this 52 times. Let's see if it can guess what capital A is. Or if it even knows capital A will come next. Nope, it has no idea. But I bet it will get B. Yep. Alright. F. It's probably a better way to do this, but we're so we're so far along. I don't even care anymore. We're just doing it. All right. There we go. And then finally, constant score equals shared items dot. I mean, I guess we can map this first to shared item score map shared item. Then we'll reduce that to just a simple sum. Return the score. And that matches, it passed our test. So that's good. Let's go ahead and run it. Without the test and without the watch. Throw our answer in. No matches. Okay. Does it say what to do if there's no matches? Or what to do with an odd number? Let's do this. I'm going to set a breakpoint over here and we'll figure out from this what's going on. Like what's going on with the rucksack that this was failing on. I never know how to like debug stuff in Node. So I'm just going to like take our actual data. Oh, it's because I didn't put any data in there. I guess I never grabbed this. Copy all that. We'll drop this into our actual stuff. And now let's try it. Okay. Yeah. That seems low to me. Maybe not. Oh. There we go. Seems like I'm losing. Like, I'm just freaking out my computer sometimes scrolling left to right. All right. So part 1 was done. What's going on with part 2? The elves come to you with another issue. For safety, the elves are divided into groups of 3. What are these elves doing, man? These elves carry the badge that identifies their group. For efficiency, within each group of 3 elves, the badge is the only one item type carried by all 3 elves. Then all 3 elves will have item B somewhere in their rucksack. What? The problem is that someone forgot to put this year's updated authenticity sticker on the badges. All of the badges need to be pulled out of the rucksack so the new authenticity stickers can be attached. Additionally, no one wrote down which item type corresponds to each group's badges. The only way to tell which item type is the right one is by finding the one item type that is common between all 3 elves in each group. Every set of 3 lines in your list corresponds to a single group. Okay, so that's one set of lines, but each group can have a different badge item type. So in the above example, the first 3 lines, okay, and the second groups are the next 3 lines. Got it. In the first group, the only item type that appears in all 3 rucksacks is lowercase r. This must be their badges. Okay. So this is, it's like a similar problem, but it's like, instead of cutting each one in half, I guess we're combining each one by 3. Priorities for these items still must be found to organize. Here they are 18 for the first group. So these is 70. Okay, so do the same thing we've done. We'll take all of this, throw it into here, because it's the same data sets for both halves of the test. I wonder if this is the case for everyone, because then we could have maybe fixed the starter a little bit. But here, the answer is 70. And I think we'll probably do something similar to what we did last time too, or just copy paste most of it over. Because, okay, the score map is definitely still relevant. I guess the rucksacks, we really don't care about the 2 compartments anymore. Finding the shared item, I guess, is going to be more interesting. Because we can't just, like, because there's only 2 things in the set the first time, we could have just done the map, the hash map for the first one, and then just like this, like just iterating through each ones of the second set. And we knew there was at least one that matched. So I guess it's going to be like, we're going to have to do like a hash map for the first rucksack. Then for the second rucksack, we're going to have to narrow that down, really, to be like, yeah, I guess it's just a narrowing problem, right? Like, we'll just do the same thing, put all these to true, and then for the second elf's rucksack, do the same thing, but we'll say if the first compartment, instead of like returning it, we'll just say first compartment map item equals, I guess maybe what I could do is like set it here, instead of using true, like use the marker as 1. Then we'll say if it's 1, then make it 2 here. And then inside of this last one, inside of the last loop. Okay, I got it. Let's go ahead and do it now. So rucksack. So instead of rucksack, this is just going to be groups. So we'll do type groups. First rucksack. Second rucksack. Third rucksack. And then for parsing the input, this is going to be even easier, maybe. It's just going to be different. So for parsing the input, this is going to be a group array. And yeah, I don't even know. I guess it's just like, we don't have to be so fancy with the functional stuff. We'll just say for constant line of input, here we'll have constant groups. Is a group array. Return groups. Right. So did that just work? Now constant line of input. Yeah, that's not gonna work. I hate to do it this way. I equals 0. I is less than input dot length plus plus. Then we're going to say if I mod 3 0. No, you're so off. You're so off. Groups dot push first. Second, third, yeah. Then we'll say first rucksack, I guess, would be right here. So we could put line there. Oh, I guess we don't have line anymore. It would just be input I. Else, if it's 1, then we could say groups. Yeah, there you go. Yep. I don't like it, but I think that works. So we'll say constant groups, parse input data, console.log groups. Let's see what's going on here. So we'll say test day3b, hit the watch there, and just I want to make sure my groups are right before I continue. Let's see if that matches. Yeah, it looks right. Okay. Matches up. So now we just have to do the same thing like we did with the 2 halves of this. So it's like find shared item, but it's exactly like I was describing earlier. So find shared item, but here it's for a group. It's going to be a string. It's going to be a rucksack instead of a compartment. Third rucksack. All right. So our item, I don't know, our items map. I don't know. So we'll just say first rucksack dot split, and we'll do this. Get out of here. So this one we'll set to 1, right? So 1 just means it's in the first one. And then we'll go for each item in the second rucksack. If items map item equals 1, then items map item equals 2. And now for each item in the third rucksack, if items map is 2, now we can return the item. All right, so instant shared items equals groups map shared items. let's shared. Let's console log that. So R and Z, was that match? R and Z. Yep. Boom. All right. And now constant score. We'll return the score equals shared items dot map item to the, yeah, it knows what to do. Score map. Do I not have the score map? I'm just copying and pasting the score map. Copy, paste, score map, get the sum. So we got, okay, test passes. Hope we don't get anything more where we have like the test passing, but the answer's wrong. That's the worst. All right. Hey, 5 gold stars, and we're an hour in. I think we might hit our goal of trying to get 10 by the end of the day. All right, day 4. What's up? Space needs to be cleared before the last supplies can be unloaded from the ships. So several elves have been assigned the job of cleaning up sections of the camp. Every section has a unique ID number, and each elf is assigned to a range of section IDs. However, some of the elves compare their section assignments with each other. They've noticed that their assignments overlap. To try to quickly find the overlaps and reduce duplicated effort, the elves pair up and make a big list of the section assignments for each pair. Okay, so that's our input. For example, consider the following list. Okay. The first pair of elves, the first elf was assigned sections 2 through 4, while second elf was assigned sections 6 through 8. The elf in the second pair were each assigned 2 sections. The elves in the third pair were each assigned 3 sections. Okay, got it. This example list uses a single 8-digit section IDs. To make it easier to draw, your actual list might contain larger numbers. Okay. One of their assignments fully contains the other. For example, 2 through 8 fully contains 3 through 7. Okay, got it. In pairs where one assignment fully contains the other, one elf in the pair would be exclusively cleaning sections their partner will already be cleaning, so those ones most in need of consideration. This example, there are 2 such pairs. How many pairs does one range? Okay. All right. This is going to be a pain in the butt because I think it's mainly just figuring out how to parse out this input, but that's all right. It doesn't look like it'll be too bad to parse out. So let's close out everything with day 3 so we can open up day 4 with a fresh mind. Boom. Let's actually get our tests or our actual data set this time so I don't get confused again. Yeah, that's a lot. Okay. Dump it in. I feel like maybe like tuples might be the best way to tackle this. I'm not sure. All right, and then day 4, the test, we wanted it to be 2 was the answer. So let's start that off. We'll say day 4A, test day 4A, and watch it. So it fails because we gave it 0, but it wanted 2. Yep. All right, we'll hide that until we're ready to look at it. We can get rid of that. that. So I'll put this off to the side when we actually start to solve it. Okay. Like there. Okay. So I guess we need to figure out how to parse the input. I feel like that's going to be the hardest part of this. And otherwise, it's just like a hash map problem again, like what we had done before in day 3, which was just like, we'll make a hash map for the first day and say like 1 false, 2 true, 3 true, 4 true. And then we'll go through, once we have like the inputs for here, we'll just say, okay, go through each one of those. If any one of those is not contained in our first hash map, then it's a 0. And if all of them are contained, then we return a 1. I think that's all it is. So it's just a matter of like figuring out how to parse out this input. So I think I'm just going to have it like each line return 2 arrays. It's like first and second, and those will just like return a number array. And we'll just do it like that. There may be a better way to do it, but I think that's reasonable. So we'll say function parse input. We'll say type pair. First is a number array. Second is a number array. So we'll say this is a input string array. Return a pair array. I don't like this. I don't know what that is. It hurts my brain just looking at it. Stop. We'll just say return input.map line. Let's just do another function down below. Function parse line. So this is like input is a string. Return a pair. So we'll say constant first, second. Yeah. Copilot knows essentially where we're going. Split it by the comma. And then, no, that's not quite right. Say first input, second input, right? Then we'll say first starter equals first input, first starter, first ender. Split it by the dash dot map item parse int. What is this parse int? Radix, the base number. I'm assuming I don't know exactly how that works, so I'm just gonna do something I know works. Right, that'll do it. And then we'll say for let I equals first starter. Yeah, it knows where we're going now. So we'll say constant first number array. First step push I. Yeah. We just do the same thing. Yep. How's a second? Copilot knows where we're going. I feel like this is what I end up using Copilot for most of the time. Like it can anticipate where I'm going, and it just helps me type. Which I want to get better at typing. Man, I've been watching Primogen. He is so quick with the way he's able to do those inputs. That's awesome. I wish I could do that. But in the meantime, Copilot's great. Part line. Let's make that parse line. Parse line, like so. Cool. So constant pairs equals parse input. So this console log the pairs to make sure we're on the right track. We've got our test running already, so we'll see what's going on here. That looks right, right? 2, 3, 4, 6, 7, 8. 2, 3, 4, 6, 7, 8. 2, 3, 4, 5. 2, 3, 4, 5. I guess we can just look here. 2, 3, 5, 6, 7, 7, 8, 9. 2, 3, 4, 5. Yeah. Yep. Yeah, see, I like I said, I'm pretty sure this one's just going to be a pain in the ass to parse. We've gotten past that one, so it's just a matter of like writing our true false function. Oh man, I'm blanking on the word. Predicate. Our predicate function to say whether this one is totally compared or not. Okay, function totally encompassed. Will the first one always be the one encompassing the second? I don't think so. So that sucks. We gotta check both ways. I was thinking it would only ever be the first way. That one of their assignments fully contains the other. I guess we could just always sort these two things. We take 1 and 2, and we should always just make the longer one first. That should work, because we'll just always make the longer one go first, because if one's ever going to totally encompass the second, it will have to be the longer one. Fully encompassed. So this is, so given a pair, we'll return a Boolean. We'll just say, no. What? Constant sorted. What even are these? Sorted assignments, I guess. Pair dot first, pair dot second, sort a dot length minus b dot length. Right? And then we'll say constant first second. So I guess my data structures are dumb because I totally didn't need to name things that way. It's whatever. So we'll say constant first map. Everything's just hash mapping, man. First dot reduce ack item. Nope. Sometimes I swear I just fat finger stuff. Ack item is true. Return ack. Yep. First map is there. Then we'll say for item of second. Let's just have this actually, instead of a Boolean, we'll have it return 0 or a 1. Yep. Return 0. Otherwise, return 1. Cool. So now we'll say constant results equals pairs dot map totally encompassed. Let's keep that up there. Let's do another one here for results. Let's compare this with what it was supposed to be. No. Still doing something wrong. All right, we gotta return the sum. return results, but that still should be 0 because everything in there is 0. So something's wrong with our totally encompassed thing. So first map is true. I don't know what would be wrong here. So the inputs are still correct. I bet my sorting's wrong. Let me just try doing this. Hey, there we go. I knew it. All right, let's make sure there are two such pairs, and it was the before last and then the before last. That's kind of what we had here. All right, I think that's right. We'll go ahead and remove the watch, remove the test. That should give us our answer. Ooh, excuse me. All right. 498. Hey! There we go. What's going on in part 2? I don't like how it's... I feel like part 2 is going to be hard. Okay, it feels like there's still quite a lot of duplicate work planned. Instead, the else would like to know the number of pairs that overlap at all. Oh, this is actually easier, right? The above example don't overlap, while the remaining 4 do. So we wanted to say the number of overlapping. I think this is just the same thing. Thankfully, like the parsing here is going to be exactly the same. I have a feeling that, see, when I had done this before, I thought I remembered that there'd be times where you'd get separate data sets for the first half and second half. Maybe that's still coming. I don't know. But in the meantime, this is fine. All right, so B said the expected answer was 4. To be 4. Okay, let's get rid of most of this. Get rid of that, get rid of that. And let's put B over here. I feel like I'm just going to do like what I did before. Just copy most of this. Then we're just going to change. I think we just want to change like the one, the one line. Or I guess the one function, right? Totally encompass. So instead of totally encompass, this needs to be any overlap. Okay, we can get rid of A now. Let's go ahead and start our watch on test for B. That's so weird. I wonder why it's doing that where it's running all the different tests. But okay. So expected 12, but got 45. Is that right? Wait, what? How's that even? Oh, why am I running day 2? Oh, it must have been me hitting A for all. I just definitely try to fix that in the starter. Probably off stream though. Totally encompassed. Yeah, so that needs to be switched. Any overlap? All right. So any overlap here. I feel like it's just like that, right? Because now order actually doesn't matter, so we probably don't need to sort, but it's not hurting anything to sort them. But if any of the ones, yeah, this should be it. Okay, 4. Wait, is that right? So this would say would like to know if the number of pairs that overlap at all. Okay, so let's make sure that makes sense given the inputs for day 4. I feel like maybe I got this wrong, but we'll see. It says, okay, the first 2 pairs don't overlap, while the remaining 4 pairs do overlap. Okay. So it should be 001111. So I'm still this isn't outright, essentially. So we'll say first and second. Let's just get rid of the sorting. Do structure out first and second from the pair. So our map, this should still be the same. We'll make a hash map with each one of the items in our first. And then I think it's if there is, yeah, they do have any overlap, we'll return 1. All right, let's try that. Yeah, that looks right. That looks right. Okay. All good. All right, let's try it with the actual results. We'll see how we did. Day 4B. 8:59. Hey! Alright. We're storming down these, bro. See what's going on. The expedition can depart as soon as the final supplies have been unloaded from the ships. Supplies are stored in stacks of marked crates, but because the needed supplies are buried under many other crates. Oh gosh. This parsing is going to suck. What are they doing? The elves don't want to interrupt the crane operator during this delicate procedure, but they forgot to ask her which crate will end up where. They want to be ready to unload them as soon as possible so they can embark. They do, however, have a drawing of the starting stacks of crates and the arrangement procedure. What is this? Okay, so there's a series of stacks. Move 1 from 2 to 1. Okay, so it's just like popping off our stacks. Like this is going to be all parsing of this nonsense. I'm going to hate it. Okay. Okay. So when we move 3 from 1 to 3, what is the order in which it happens? Okay, so we pop. Okay. Yeah, I get it. I get it. Then at the end we have to say, so it should be CMZ. Okay. Man, what a pain in the butt. Day 5, let's go. Okay, so our test data looks like this. And our real data, I bet, is going to be nutso. Man, what a pain. What a pain. All right. I wonder if it would be worth it to just like go through and manually adjust how these read, because this is such a pain in the butt to parse. Is that at least like uniform? Could I split it like every? What if I could like tokenize 3 spaces? I don't know. I don't know how I'll parse this out. I guess I feel like the best thing for me to do is actually just to manually go in and adjust these to make the input more reasonable. I hate to do it, but I think that's the best way. So like we'll do like Z and N, and then M, C, and D, and then P. And just pray that this doesn't mess things up for part 2. Yeah, this is gonna suck too. Okay. F, T, C, L, R, P, G, Q. F, T, C, L, R, P, G, Q. Yeah. N, Q, H. What is Copilot thinking right now? R, F, S, J. It's totally bewildered by this. Nope, not even close, Copilot. B, H, W, P, M, Q. V, S, T, D, F. Q, L, D, W, V, F, Z. Z, C, L, S. Z, B, M, V, D, F. What? T, J, B, Q, N, B, G, L, S, P, H. All right. Let's hope we didn't make any mistakes. There we go. All right. Now let's go into parsing this out. Let's get our test answer in here. So expected CMZ. So I'll paste that here. And set parse function, actually parse data string. Copilot, come on. What are you doing to me? What do we call type data, I guess. So we're going to have our stacks, which is yeah, I guess it's a string array. But it's like a one index string array. I'm actually going to make that a record. Record of number to string array. And then we have our instructions, which is, how do we parse that out? Move 1 from 7 to 4. So it's going to be like remove from count and target and place into, I guess. Let's call it something like that. Remove from is a number. Count is a number. Then add to is a number. So this is a string array already, and we want to return data. So we're going to start, constant stacks instructions, data dot split. One should just be like this, I think. Log stacks and instructions. String array. Oh, I wish that did I wish that did appear in here. Let's just do it like this. We'll say stacks equals this. Const instruction inputs let empty line countered is false. Constant line if line is empty, yeah, I guess we do need to continue there. So then if not empty line encountered, stacks.push split. Yeah, I think so. Yeah, I think that's right. This might get weird with like what's on the bottom and what's on the top. And then we'll say else. I guess we probably need another parsing function just for how to parse out the instructions. I guess we could just like erase all those as well. So it's just like how long is this? Okay, let's say, is there like replace? Yeah. From move then to oops, that's not right. Need to leave a space there. There you go. Let's just say everywhere there's a double space. We're going to replace that with a single space. That looks nice. All right, that's much better. Do the same thing here. Oops. There we go. Messing with the inputs. Instructions. Dot push. I'll say this is like constant. What do we call this? Remove from count and add to equals line map. Nope. Map. String. Oh, is there? Oh, this is a. Ugh. Okay, I guess I got a map on the other side. Yeah, that's all I needed to do. So this should be number. Yep. And then we'll just say, yeah, there you go. Instructions. Okay. So now we can return instructions. Stacks we actually have to change up a little bit. For let I equals 0, that's less than stacks length, I plus plus. We'll say, let's call this stacks array. And here we'll have constant stacks. Stacks I plus 1. Okay. Let's see if we parse that data out. Constant parsed. I guess this is just, yeah. Parsed equals parse data. See if that matches what we expected. And we'll have to actually start popping. All right. So we'll watch day 5A. I wonder if this is a weekend one. Aren't the weekend ones supposed to be harder? PCMZ and it got 0. Okay. So ZN MCD NP. MCD NP. Move from 1. Did I do that wrong? I feel like I did that wrong. Move 1 from 2. Yeah, I did that wrong. I'm glad I caught that there, though. Because... So this is count. Remove from is here. Let's just switch the order of that in the object literal too, just to make it less confusing. Move 1 from 2 to 1. Okay. So now each one of these is going to return new stacks. Um, so it's really like we just want to pop and push, or not push, but well, we're gonna have to like recreate the stack with the array. And I think there's a way to like remove something from the. What does pop do? Let me just see. I think pop gives you back JS array pop. Is that going to. Okay. Pop removes the last one. And then there's like array dot. Is it DQ? There's some method for that. Add. Oh, is this just push to end of array? Yeah, I'm pretty sure that's just push, right? Yeah, it's just push. Duh. All right, just pop and push. Makes it easy. So we'll say, really, this is going to be, we'll say function perform instruction. So this will actually take a stack, data stacks, and it will return that, but we'll also need one instruction. Instruction is, so I don't want the count in here actually, but I do want to remove from as a number and then add to as a number. Doesn't like this. Oh, is it because of the implementation that it added? All right. So we'll say constant copy equals key in stack copy key, spread it. Yep. And then move from, add to. So this will just be like an atomic move. And we'll say, yep, copy remove from dot pop, and then copy add to dot push removed, and then return the copy. I wonder if we want to do like currying here, because this might end up being like recursive. I think we can just do an iterative approach actually. So we'll say stacks and instructions. And here we'll say let current stacks equals stacks for instruction of instructions, and then for let I equals 0, I is less than instruction dot count. Current stacks equals perform instructions, current stack instruction. Then I guess the last thing to do is get the function get answer. So given stacks is data stacks, return a string. Does it say what to do if the stack is empty, or will the stack just never be empty? Hopefully the stacks just are never empty. I don't know what's going on with that. It seems like the stacks could be empty, but maybe they're tailoring the inputs to make sure they're not. So we'll say constant constant answer R is a string array. So we'll just do like a string builder here, and then at the end we'll turn answer dot join. Yeah. For key in stacks, answer dot push stacks key stacks key length -1. Yeah, I think that's right. Okay. So then we'll return get answer current stacks. Hey, all right, we passed the test. Let's go ahead and try it with the actual data. I hope there's not something wrong here. I don't think there is. See if that works. I really hope it does, because I don't want to debug this. Hey! All right, part 2. What's going on here? Oh, no. Some mud is... Oh, no. The ability to pick up and move multiple crates at once. Okay. Yeah, that was too easy. Yeah, but moving 2, they stay in the same order. Okay. So this is going to be like slicing instead of like doing these atomic things. So that's fine. So it should be MCD is the answer. All right, so we'll take our data, paste it. I'm really actually happy that I didn't make any mistakes there in the input, because that would have been very possible. But let's take day 5B spec. So we want this to be MCD. And we'll start copying and pasting over our solution from A. Let's move that there. This is going to take it all. And we need to like change the way the parsing can stay exactly the same. It's just the way that we process an instruction. So let's get rid of A now, and let's start the watch. Watch test. All right. All right. Sit watch. Okay. That looks right. So what we're going to want to do, get rid of that. Then the instructions, perform instructions should be at this point. This is just data instructions. What? What isn't like about this? Oh, number. Yeah. Then account. All right. So we're still going to make our copy. Removed should now be a string array. And this should be copy dot remove from. Is that it? I think that's it. Because Splice will give me the ones it removed. Let's see if that works. This should not be push. This should be concat. Oh, that didn't work. We just got P. All right, let's do this. We'll console.log current stacks. All right, let's see what's going on here versus what we expected, because it kind of gives us all that. Crates begin in the same configuration. ZN, MCD, and P. Yep. Moving a single crate from stack 1 to stack 2 behaves the same as before. So that should just be... No, we just got rid of it. Okay. So this actually removed the stuff we wanted it to remove, but it didn't actually put it on. I thought that's what Splice returned. Console.log removed. Oh, yeah. Copy, add to, equals. There we go. All right, there we go. That's more what I was looking for. Let's hope this works. Comment that out, because that may be helpful next. All right, let's try running it for real. See if that works. Yay! I'm so relieved I don't have to debug that one. Oof. Cool, y'all. Let's see. We've been at about 2 hours. I'm still feeling all right, so I'm going to keep it going. Let me put on Twitter something real quick, just to let people know we're here. I'm going to take a quick break. Just to use the bathroom real quick. There you go. 10 stars down. There we go. All right, I'll be right back. Actually, let's read it before I go take my break, because I kind of like being able to ruminate on one. See what's going on here. Preparations are finally complete. You and the elves leaves camp on foot. Begin making your way towards the Star Fruit Grove. One of the elves gives you a handheld device. He says it has many fancy features, but the most important one to set up right now is the comm system. However, because he's heard you have significant experience dealing with signal-based systems, what is this? Oh, this is previous years? I don't know. He convinced the other elves that it would be okay to give you their one malfunctioning device. Ugh. To be able to communicate the elves, the device needs to lock onto their signal. The signal is a series of seemingly random characters that the device receives one at a time. To fix the communication system, you need to add a subroutine to the device that detects a start of packet marker. Oh, in the data stream. Okay. This might not be too bad. I don't know. The protocol being used by the elves is indicated by a sequence of 4 characters that are all different. Okay. Your device will send your subroutine a data stream buffer. Your subroutine needs to identify the first position where the 4 most recently received characters were all different. Okay. I mean, it's going to be like an n squared. It's going to be like an n O log n or O of n solution, but it's like 4. Yeah, it's like fine. It's fine. I think that's like the best way to do is just like brute forcing through. 1, are there any matches? 2, are there any matches? 3, are there any matches? No reason to get weird with it. After the first characters, there have been enough received yet to find the marker. The first time a marker... Oh, but it's like retroactive. First time a marker could occur is after the 4th character is received. Because J is repeated, this isn't a marker. The first time a marker receives is after the 7th character arrives. 4, 5, 6, 7. So, yeah, that right there. Okay, the last 4 characters, which are all different, in this case, should return a 7. Okay. Okay. This shouldn't be that bad. All right, I'm going to take my break, like I said. I'll be right back. Just leave this on for now. All right, be right back. All right, I'm back, y'all. Let's put my face up so y'all can enjoy it. All right. So this is interesting because there's actually multiple inputs here, which kind of like clashes with the pattern that we've been seeing. But I think it should be fine. We'll just use like the 1. I think that should be enough because this is simple enough. So we'll copy this. We'll put it in, I guess this is day 6. We're moving right along. 6A, paste it. And we'll just use the first one. first example, because I don't think this is that complicated. It may get complicated in part 2. I have a feeling it will be, but that's fine. So day 6a spec. So this should be a 7. Cool. All right. So we'll read in the data. Really, I guess we're just going to like split it up, make it into an array of single character strings, just because I don't want to deal with like substring and stuff like that. And then we'll just, yeah, I mean, I think it's just like brute forcing this is fine. So I'm not even going to make a function for parsing the input. I'll just say constant input equals data dot split 0 dot split. Yo, what's up, dude? Oh man, sorry to hear, dude. Yeah, we got 10 stars so far, so I'm pretty happy, but we'll see. I want to see how far we'll go. I'm still feeling pretty good. I'll probably like wrap it up in probably another hour or so. What's your night routine though? I'm curious. Is that like workout, or is that like time with the family? You got 0. Well, I had 1 at the start of today, so I'm taking it as a W. I got caught up. I actually got I trusted GitHub Copilot a little too much, and that threw me for a bit. I would have been further if it wasn't that. But yeah. Oh yeah, good deal. Yeah, I try to do my workouts earlier, but I've been bad at that recently. So I'll need to get into that more. Hopefully, once I'm off client work, I feel like that'll be easier to just go right there in the morning. But yeah, good on you, dude. You put it in the work. I love to see it. Yeah, I had reduced time with the kids today too. I took them, we went on a walk and we had like 15 minutes at the park nearby us. So that was fun. I stopped working. Okay. Yeah. I don't know. For me, so I'll do like a workout and then I'll do a like 20 minutes in the sauna and then I'll do a cold shower. And after that, I actually feel really energized. So yeah, that's my little routine. So what I hear though is it's actually much more beneficial to do the cold shower first before a workout and then like come at it cold. Using Dino for AOC? Yeah, sure. I mean, it would work. It's probably faster, maybe. Yeah, it probably would be faster. It would be nice to just deal with the native TypeScript too, but it doesn't really matter. Like this stuff is going fast enough. It's not like we need to use Rust or anything like that because our TypeScript's going to be too slow. If it's too slow, it's because our algorithms are too slow, right? So, all right, let's get to just brute forcing this. I think for let I equals, I think we start with like index 3 as less than input. I think at some point we would just return inside of here. So we just say, let's say last 4 equals, yep. Copilot is nice for saving the typing. Oh, that's a great idea, Copilot. If unique size is equal to 4, then we can just return I think. Yeah, that was really nice. I actually wasn't thinking that, but that was, as soon as I saw what Copilot was thinking, it made sense. All right, let's see if that works for day 6. Do test. We'll do a watch. And just in case it doesn't work. Yeah, it worked the first time. I'll go ahead and run it with the real data. So get rid of test, get rid of watch. Let's see if that works. Nope. Ah. All right, back to day 6. What did we do wrong here? I guess let's try doing the other examples and making sure if those ones are okay. So we'll do test data, but before I run it, I'll replace it with that. So this should be the second one. So we should get an answer of 5 here. No, it got 7. Why is that? Guess let's do this. We'll console.log as we go. Console.log. Let's run that again. J. Maybe I misunderstood, because that should be first marker after character 5. Oh no, that should be right. Why is the answer 7 there? Oh, I plus equals 4. I don't know what that was. I think that was our bug. That says it was 4. It says that should be 5. Marker after character 5. 1, 2, 3, 4, 5. All right, I guess we just have to do turn I plus 1, I think. Let's try that. 5. That looks right. It's right against the real data. Try that one. See if that works. There we go. I think that was Copilot. I hope that was Copilot and not me that made that mistake. Okay. Looks like we're going a completely different direction here. Your device's communication system is correctly detecting packets, but it still isn't working. It looks like it also needs to look for messages. A start of message marker is just like a start of packet marker, except it consists of 14 distinct characters rather than 4. Okay. So this is completely different, I guess, than the first one. Like the start of the packet doesn't matter at all. A packet, a message isn't a child of a packet. A message is just its own thing, I think. Let's try it again. So we'll copy this one and we'll set the test What did it say? 19? 19. And for day 6 B test, paste that in. And I think it's the same input. So we'll do like this. I'm just going to brute force it again because that was fine. Let's get rid of everything here. I'm going to start the watching B test. When it's right, it's us. When it's wrong, Copilot. Exactly. Just blame Copilot. That's its job, is to take the blame. All right, let's see what's going on here. Because I think what I'm going to want to do is just like literally do this for for the last, what was it, 14 distinct characters. Yeah. All right, so this would be 13. And we'll just say last set is that for let j equals 0, j is less than 14. Last set dot, nope, yep, last set input that minus j, unique. Probably taking an extra step here, but that's fine. And if unique size is equal to 14, oh, I'm still in day 1A. Copy all that and just drop it into day B. Then I'll undo it. Undo. There you go. All right. Got the right answer in my test. Let's try to do it with the real data. See if that works. I hope so. Yay! Day 6 done. Easy peasy. It shouldn't have been that easy, but it was. All right, what's going on with day 7? What? What's up, Chow? What changed? Oh, here's what changed. So this was the first half. It was sets of 4. We had to check the last 4. In part 2, we had to check the last 14. So just did the same exact algorithm, just did more of them. So it was fine. I think so the time complexity of this is still linear, I think, because whether it's a 4 or a 14, that's a constant. So it would be like 14 times however long our input was, or 4 times however long our input was. Either way, it like amortizes out, or not amortizes out, but it reduces down to linear time. So that works. Yeah, sorry. Sorry. I also made the mistake of making the change right here in part A. And then so I had to I just copied it and pasted it into part B, and then had to undo everything from the first half. But yeah, let's see what's going on with day 7 here. Hear birds chirping and raindrops hitting leaves as the expedition proceeds. Occasionally you hear much louder sounds in the distance. How big? Okay. The device the elves gave you has problems with more than just its comm system. You need to run a system update. What? No space left on device? All right, dude. Hey, thanks for stopping by. Appreciate you coming through. I'll catch you tomorrow, bro. Have a good one. All right. So perhaps we can delete some files to make space for the update. Oh, this is going to be a pain with parsing in the input again. You browse around this file system to assess the situation and save the resulting terminal output. Oh, God. Oh, this is the actual puzzle input. Oh, wait, no, it's much worse, I'm sure. Ugh. That sucks. Okay. Well, is it doing just like a depth first traversal? I should probably let's just keep reading first before we go into that. Here there are 4 directories. Okay, so there's that. I feel like the best way to do this is going to be... Oh. Yeah, parsing this is going to be just a pain. Alright. I get what it's trying to do now, at least. It consists of a tree of files and directories. The outermost directory is called root, or whatever that is. You can navigate around the file system. Lines with are commands you executed. CD moves in, moves out, and we could switch back to the top. ls means list. Yep. So if we list, and it looks like, so when we list it, it'll either give us that it's a directory or that it's, what is this? Hopefully that's not anything weird. Size 123. Given the commands and output in the file above, you can determine. Okay. Here there are 4 directories. Since the disk is full, your first step should probably be to find the directories that are good candidates for deletion. To do this, you need to determine the total size of each directory. The total size of a directory is the sum of the sizes of the file it contains, directly or indirectly. So all descendants. The total sizes of the directory can be found as follows. Okay. Its total size is that. Some already got it. Find all of the directories with a total size of at most 10,000. These directories are A and E, and their answer is that. Okay. First of all, find all the directories with the total size of at most 100,000 bytes. What is the sum of the total sizes of those directories? Okay, so anything less than 100,000. All right, we'll figure this out. It's going to be a pain in the butt. but it's doable. Excuse me. Okay, day 7. Day 7 test. Dump it in, and we'll get our actual one. So input. Paste that in here. Save it. Let's go into day 7. The parsing here is going to be like nuts. But everything else is like pretty simple. So like the parsing should give us like a tree node. So if we said like interface directory is, so this should have, I guess we should just say files. Just name, size, and directories. It's a directory array. So that's our tree interface. So we should have a function here, parse directory, input is a string array, returns a single directory. This one's going to be fun. So say let current path equals slash, because we start there. And I guess we'll just like iterate through each line. Let's do it this way. We'll say for let I equals 0. No, we'll say while let I equals 0, while I is less than input dot length line equals that. Don't think that's useful. Maybe it was. I don't know. I don't trust Copilot for that, for better or for worse. So, but yeah, we'll say if line starts with $, right? Let's put our tests thing over here. Actually, let's before we do that, we'll go ahead and run. Make sure we have the answer keyed into our test. Oh, what happened there? Get out of there. Ah. There we go. Yeah, I don't know what happened there at all. Day 7, a spec. All right. So we want this to be what? This. Copy. Paste. Let's just start watching that. Cancel. NX test day 7A. Watch. Okay, so right now we're getting 0 and expects. What? Oh, it's failed to parse a file. Because this is. Yeah. Turn files, directories. Okay. So now it's at least compiling. All right. So we'll have to figure out how to traverse through here. So if it starts with, maybe we should just do it like if it starts with $CD, then we'll set the current path to there. Is this? So we'll have to be like updating our current path pointer. So let's do that. If line starts with $, CD, current path equals, so we could CD what did it say we could do? We could CD in one level, we could go out one level, or we could go back to the root. Okay. So let's do that. We'll just say if line starts with that, if line, no. Come on, Copilot. Get it together. If line starts with $CD this, current path equals that. All right. Line starts with CD that, yeah. So then last index of, I think so. I think you're right, Copilot. Else if, I guess this would just be an else at this point. Line slice 5. 1, 2, 3, 4, 5. Yep, I think that's right. So those ones will set our current path. And then I guess what we want to do is like start with the current path, because when we hit ls, so we're going to have here constant path map equals new string, new, no, I just want to do an object literal. So this is a record of string to, what is this going to be? This is going to be dir names string array, and then files. It's going to match this. Paste. Right? What is it like about that? Oh, this needs to be like that. Like that. Like that. There you go. What doesn't it like about this? Path map is assigned a value but is never used. Yeah, we'll do that later. So otherwise, so we'll say I++ here, else if line dot starts with ls. We need to like parse in each line after that. files. I guess we could do like this, yeah. Just like bump it up inside of here. I think CodePilot's on the good track. It's just this is wrong while input was not the case. That input I starts with $sign. Then we can keep going. If input I dot starts with dir, dir names dot push input I dot slice 4, I think. Yeah. Else constant size. Yeah, good job. Size equals plus size. Files dot push. Yeah, that looks good. I think that does it. While boom. I think that works. And then we'll need to like take it from a flattened one to a tree. Yeah, I think so. Path map. All right, let's just see what that does. Console.log path map. Let's just say constant file system parse directory data. Okay. Oh, it's not the case. All input I and let's try that. Okay, so that compiled. That's not right though. Dir names. What did it say it should look like? Stir. Maybe I'm just putting an extra thing in there. A. So that had directories A and D. Yep. And then files B and C. B.text. Yep, I think that's right. I'm just adding an extra slash there. Why am I adding an extra slash there? Crib path. I guess right here. I should get rid of our double slash. Okay, I think that's right. terms of parsing it. I wonder if we could actually stay flat and be able to figure it out. I think we probably could. Let's just try seeing if we can solve it like this. If I just, so here, if I just return the path map, instead of doing like something recursive. So path map, what did that look like? Record of this. So file system, let's get rid of this here, make sure that's working. Okay. So now, function get small enough gers from our file system, which looks like that. So this should be a string array, yeah. And then so we'd say small enough dirs, get small enough dirs from the file system, and then get sum of sizes given the small enough dirs in the file system. So how would this look? Sum of sizes. Yep. It knows how to do that. Yeah. Files. Actually, I guess we should just do it like this. Let's have this, yeah. Instead of just being a string array, we'll just have this be dir name is a string, size is number. Then that should just be able to take in copy that. Sizes. Turn small enough dirs. Dot map. Size. Size. Reduce. Yep, you know what to do now. There you go. All right. So still need to get our small enough dirs. What doesn't it like about that? Oh, that needs to be an array. Get small enough dirs. Array. All right. Okay. So constant size limit equals 10, 100,000. So we're gonna say I don't know what it's doing there. That looks like cheating for everything it was doing. But yeah, let's say I mean, I guess we could just. It would be nice to do it recursively. I guess we could just say if starts with. Yeah, I mean that's gonna. It's gonna take a while to parse. Like we might run into time complexity issues, but I think I'm just going to try doing it like brute forcing it first instead of like doing some recursive tree approach. Um, so we'll say for constant dir name. Let's see what Copilot's suggesting here. Let's get rid of this for now because that's not really helpful. Their names and files. Yep, that looks right. Size. That's not quite right. Yeah, that's not quite right. We're going to have to say. I think we feel like we're going to have to be recursive anyways. Maybe. Let's just say constant all files equals files. Then we'll say for, yeah, this is definitely getting into n squared territory. For dir name of object dot keys. I feel like we'll be able to handle this. If not, I know how to, like, we'll just go to a tree so that we don't have to do the n squared solution. But I'm like okay with this at this point. We'll say there. I'm going to erase everything after this because I don't know what that's doing yet. So we'll say if dir name all files dot push everything on there. Yep. Constant size equals that. If size is less than size limit, so here's like our constant small enough. That it's specifically this shape of array. Yeah, and then here we'll return small enough. And here we just push on small enough dot push dir name and size. All right. Let's see if that works. Oh, returned answer. Took a while and still gave us 0. So that's not great. For dir name. File system. I mean, that should be right. I mean, it's not performant, but it should work. So, dir name starts with that. We put this here, and I'm going to start debugging, I think. We'll see where this takes us. Hit save. I'm still getting zeros, but let's hit debug. Okay, if we step over, Okay, so this was for slash. So that should be probably, maybe that's right. I don't know. If we look at our test. So I guess you sum all those up, it should work. What did it say in the test data? Receive 4 directories, total size of directory E, no other directories. So we skip ahead. This would be A, yep, and AE. If we step over that, oh, that's way too high. What did files look like? All files. Oh. I see. Looks like shadowed name problems. Yeah, that makes sense. Other dir name starts with dir name, push, other. All right, let's see. Okay, still having a problem there. Let's see what's going on. I debug it. 7A, let's hit debug again. Dir name is A. Dir name is AE. And then all files. Oh, okay. If dir name other dir name is not equal to dir name and I think that may actually fix everything that was broken. Yeah, we're passing the test now. All right. Good enough for me. I'm curious to see how long this takes. Not long at all. I'll take it. Let's see if that worked. I'd be a little surprised if it doesn't. Yay! We did it. Part 2. All right, now I'm ready to choose a directory to delete. Total disk space available is 70 million. You need unused space of at least 300 million. Oh gosh. The size of the outermost directory is this, which means that the size of the unused space is currently that, which isn't quite that. Therefore, the update still requires a directory of at least to be deleted. Okay. That's what, 8 million. So this one would do it. Directories A and E are both too small. However, D and that are both big enough. Between these, choose the smallest. Okay. Find the smallest directory that, if deleted, would free up enough space. Okay. That's not too bad, I think. I think we like pretty much have it already just via the parsing. Like the parsing was the hard part. So let's do this. We'll take our test data, all paste, all paste. I'll do B spec for day. Wait, is this, what day are we on? Day 7. B dot spec day 7 to be, copy that. Paste it. All right, let's see what's going on. Let's do this test to be watch. Kick that baby off. Then let's get rid of a lot of these other tabs. Keep the A around. I guess let's just grab everything to start. Dump it in. Copy. Paste. Let's see, go up to the top level. Yeah, I don't need small enough dirs. Let's hide the console for a bit. Don't need this. Don't need small enough dirs. Don't need sum of sizes. What I do need is like constant total size equals 73, 1, 2, 3. Constant target size. Constant, I guess, space used. Get space used. We'll make a function for this later. Then we'll say constant target space equals that. Then we'll just need to like say constant directories big enough equals to get directories big enough with the file system and target space. Then we'd return directories big enough dot reduce like a min here. 1 ec. Return the current. Otherwise, math.min oh, I don't need that. Yeah. All right, I think that's it. You just need to do get space used and get directories big enough. So get space used is pretty easy, I think. function get space used, file system. Yeah. Files.reduce. Yeah, I think that's right. Easy enough. Function get directories big enough. So this is file system. That's wrong. Hang on. I really needed to name this type. Okay. File system, string, and that. And then I guess this is like the minimum size. Minimum size is a number. This will return, I guess it's like dir name, string, size is number, array. Yeah, I guess. All right. Let's check out. What did we do here? It's going to be like similar to this, I feel like. Because this is like essentially like a traversal, but leveraging the fact that it must start with that. So we'll do like this. Just copy this. I think that's all we'll need to do. Constant result equals grab that type. Okay. So I'll push that, then return the result. Get directories big enough. Oh, yeah. I guess we do need to do. We do need to check the size. Okay. If size is greater than or equal to the minimum size, then push it on the results. Okay. Did that give us our answer? No. Give us not a number. Why though? Is it maybe this? Nope. 50 million. Let's just do this. Const console.log. Directory is big enough. Let's see what that did. Oh, okay. Reduce cur. There we go. All right. I mean, this shouldn't be worse in time complexity than the first half, so this should be fine. Let's see if that worked. That can't be right. Is it right? The only one? That can't be right. I think this is wrong. So we need this much, right? Okay, so the total size, and then our space used is that. So our target space to clear up, let's try that. That's not right. That can't be right. Let's do this. We'll say constant console.log space used. I'm sure it's like something. It's after the file system. Okay, so there's a space used. Okay, so constant hard drive size equals 7 million. Target size equals that. Space used is that. I feel like the target space would be space used used minus 40 million, right? Okay, that looks right. I think that was my only problem, is like the easiest part. Yeah. I think that's right. Let's see. If it's wrong, we'll figure it out. But I'm ready to give that a shot. Hey, day 7 in the books. 14 stars on the plate. Let's go across this. Let me see. Calendar. That was a really hard one, I feel like. That was on Wednesday. Let's see what's going on here. I think this will be my last one. Expedition comes across a peculiar patch of tall trees, all planted carefully in a grid. Okay. The elves explained that a previous expedition planted these as a reforestation effort. Now they're curious if this would be a good location for a treehouse. What's this? Okay. First, determine whether there is enough tree cover here to keep a tree house hidden. You need to count the number of trees that are visible from outside the grid when looking directly along a row or column. Quadcopter. Generate a map with the height of each tree. Tree is visible if all the other trees between it and the edge of the grid are shorter than it. Okay, so this one would be visible and this one would be visible when looking this way. So visible trees would be, oh gosh, that's interesting. You have to like check it. There's 1, 2, 3, 4, 5 by, well, there's 10 because you go one way and then the other way, and then 20. Okay, so there's 20 different sight lines. I guess it's really just the perimeter of the square, right? 5. Yeah. Yep, it's the perimeter of the square is how many sightlines there are going to be. Only consider trees in the same row or column, that is. Look only up, down. Okay. All of the trees around the edge are visible, obviously. There are no trees to block the view. In this example, that leaves only the interior 9 to consider. Top left is visible. Yeah, okay. Top middle is visible. That one's not visible. Okay. With 16 trees visible on the edge, another 5 on the interior, a total of 21 are visible. Okay. Consider your map. How many trees are visible? All right. This one's actually should be fun. This is a lot better, I feel like, than the other ones. I feel like parsing the input is just the worst part of almost all of these. A test. Boom. We'll go to a.spec day 8 to be 21, it said, right? Expected answer is 21. Okay. Cool. So excuse me. You go here. Start by parsing it in. I guess we'll do like a record of a number, I think. So we'll say function parse input string array grid. We'll say type grid record of number to a record of number. Yeah. So we'll say this is grid, yep, equals that for line. That's not right, I don't think. Constant trees, I guess, equals line dot split dot map string. Yeah. Then I equals 0, I is less than, put dot length. Then here we'd say grid I equals that. Yep, trees equals line. Yeah, grid ij equals trees j. Yep. Looks right. Constant grid equals parse input data console.log the grid. Where does that get us? Let's start by doing test day 8 a. Okay. Yep, that looks right. All right. I think I want to do this. I want to do height, width, data. Data, grid, data, return, height. No, height should be data. Let's see. So the height is really, yeah, the height should be object.keys data.length. The width should be, yep, then data. I probably won't need that, but that might be helpful. So now we'll just say is visible. So we'll say function is visible. So that should take the grid, an X and a Y. And this will return a 0 or a 1. Now we'll say if x equals 0 or x is equal to grid dot width, return 1. If y equals 0, okay, so that should get all of our perimeter trees. Then we'll just need to figure out, I guess it's like for each one, we'll say like is visible from the north, is visible from the south, is visible from the east, is visible from the west. There may be a better way of doing it, but I don't know. Function is visible from north for y minus 1. So this would mean it would have to be taller than everything before it. Yeah. I is greater than or equal to 0, I minus, yes. If grid data xi is greater than so we're going to iterate for each tree before it. The tree before it is taller. So if it's greater than our current one, grid y x, then return false. If it gets through all of them, then we can return true. All right. Function is visible from south. Can you figure it out? I think you did. Yeah, I think you did. Let's see now. Function is visible from east. Function is visible from west. Return is visible from east, or is visible from north, or is visible from south, or is visible from west. So if it's visible at all, it's a 1, otherwise it's a 0. That looks right. So that's for is visible. So function get visible count given the grid. So we'll say like count equals 0. Yep. For I, j. Yep. So we'll say return get visible count from the grid. And that's wrong. Let's see. What did it give us? Undefined. Reading 1. Oh, did some of these not get turned into numbers? That would suck. Let's see. Yeah. Okay. Parse input. Huh. Not read properties of undefined. Reading 1. Oh, duh. Why didn't I get a type error on that? That's crazy. 46. Huh. All right, let's see if that helped. Data. Guess that's on all of these functions. And all right. That is the worst. Let's do something like this. Let's say constant is visible map is a record of number to a record of number to a Boolean. Right? Then we'll say is visible map I equals that. Is visible tree visible IJEI. Grid. Yep. Is tree visible? Console.log. See what that looks like. Okay, let's look at our test data and just see where this is coming up wrong. 8 test. Oh, I need day 8. So around the outside, that should all be true. 5 is right. 1's right. This one is correct. That one's wrong. 3. This one right here. That true should be a false. Let's see if is visible from the east. Visible from the east. Oh wait, no, it should be visible from the east. That's right. Did I just count things wrong? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. No, did I understand the problem wrong? Let's see what's going on. Five visible from the interior. The bottom row, the middle 5 is visible, but 3 and 4 are not. Bottom row, middle 5. Yeah. Okay. Okay, so that one's wrong. Wonder why though. I think that's just needs to be greater than or equal all across the board. Let's see if that fixes it. Yeah, I think that's all it was. Everything else looks solid. Let's try it with the real data. Curious what the real data. Oh, I never got it. I never got it. Wow. Wow. Let's dump that in a text. Okay. Please don't make me have to debug this. Yeah. All right, what's going on with part 2? I think this is the last one. Okay. Content with the amount of tree cover available, the elves just need to know the best spot to build their tree house. Oh no. They would like to be able to see a lot of trees. To measure the viewing distance. Okay. So this is like the opposite. Elves don't care about the distant trees taller than those found by the rules above. Be able to see higher than the treehouse. Anyways, consider the middle 5 in the second row. So it gets 1, 2, 3, 4. 5, 6. 3 scenic score. Oh, is by multiplying. It needs of the. Okay. So it's 1 by 1 by 2 by 2. So that's 4. Consider the tree height of 5 in the middle of the 4th row. So you see 2 times 1 times 1 times 2. Wait, no. 2 times 2 times 1 times 2. So that would be 8. Yeah, okay. What is the highest? Okay, so the answer for part B is 8. So we'll go to B dot spec day 8. The answer is expected to be 8. Start watching that. Test day 8B. Watch. All right. And let's go here. Parsing in everything should be similar. I guess this is going to be like, I feel like this is probably not worth keeping around. But parsing the input is. So we'll say, we'll get that. Parse the input. Probably need to know, tell it what a grid is. Where's my grid? There it is. Type grid. Boom. Stay grid. Grid parse data. Console.log grid. All right. Guess I do need to do this. Copy, paste, copy, paste. Okay. There we go. So now I think that's all we can glean out of the previous stuff. Let's get rid of the other files. We'll focus in on B. So we'll say something like function get grid view scores, takes a grid, which is a grid, and returns a new grid. Yep, that looks right. Except for that. Scores is a grid. Data, get score, pass it the grid, and I is the Y, and then J is the X. Then it would say scores I equals that. Scores I j equals score, then return scores. Right. Okay. So then function get score takes a grid. Still don't have a grid in here? Thought we had a grid in here. Oh. Let me hoist that up. Okay. So this one is turn. So it's going to be like similar. North score grid y x. Let's not get that confused. Times south score grid yx. Yep. Okay. Function north score grid yx. So yeah, we're going to go up. So each time we go, we're going to say score plus plus. And if one of them what would it be? If we're looking at this one, so this one would be able to see that one, it would be able to see that one, it would be able to see that one, and that's it. Be able to see this one, and that's it. Okay. Why though? Like obviously, okay. As long as there's a tree there next to it, it should be able to see it. But if that tree I guess here it would be interesting. This 5 can see 1 up, 1 to the left. Can see 2 down, but then can it see 3 to the right? I think so. But how does it know it can see 3? I actually don't know. Okay. What does it... Because, like, do I have to do... do I have to do trigonometry to determine if there's a sight line from this 5 to that 2? Or is it just that it's smaller than the 5? I hope that it's just smaller than the 5. I don't want to have to do that trigonometry out. Ugh. To measure the viewing distance, stop if you reach an edge or at the first tree. Oh, okay, good. So if it's just if we reach the edge, we'll stop, and if the first tree that is the same height or taller. Okay, so if that height is greater than or equal to score plus plus. Else break. Well, I guess here do nothing. I think essentially. Function south score. Yep. All right. Function east score. And function west score. Okay. Constant scores equals get grid scores. So dot log it. That doesn't seem right. Let's just look at it here. Test 8, test. So that one it's saying is 16, but that's not right. Should be 1. Okay, so we'll see north score. I is the Y, J is the X. Yep. Let's do this. Say N score constant S score E score W score multiply. I do want to hear console.log north N score south east west south east west. And before that we'll say X Y. See what that looks like. So I want to look at, let's see. I want to look at 2, 2. If X equals 2 and Y equals 2, okay, so it's got 2's all around. Which shouldn't be the case. Score equals 0. So north score should just be 1. If that I is greater than or equal to the X. Oh, then we should break. try that. Okay. Now its north score is 1. I guess I gotta do that with all of these. Boom. It doesn't like something. Did I ruin it? There we go. Break. Then here. Break. Still failing it, but I think that's right. Yeah. So 2-2 should have 1. Its north score should be 1. South score is 1. East score. Oh yeah. I think that's right. East score should be 1. Scene score, viewing distance. Care about distant trees taller than those found by the rules above. They won't be able to see higher than the tree house anyways. Stop if you reach an edge or at the first tree that is the same height or taller. Yep, that's right. All right. So, given that, yeah, it should have a score of 1. And our tallest one should be 8. That's what it said. So I just need to do like a max of all of these now. How do I do a max? I guess that's function get max of scores is grid data number. Yep. So then object dot, I don't know, keys, sure. Scores dot length object dot keys side dot length. Yeah, it looks right. So return get max scores. Hey, okay. Let's get rid of the console logs there. Yeah, let's leave them in. It's not hurting anything. Just try running it for real. Ooh. Let's see if that was right. Yay! All right. 15 stars in one night. I'm going to take that as a W. Call it what it is. How's the things looking? Interesting. I have no idea what this is. What the ASCII art is. I guess it's maybe like a tree. Maybe this is the forest they're going through. I wonder if this will be like, is that what happens at the end? Like this turns into the input for the last question. So we like day 25, we need to do them all in order to unlock. That'd be cool as hell. All right. Well, I'm going to call it there. This was fun. Maybe do some more later. I don't know, maybe during the weekend or something. But yeah, thanks all for stopping by, and I'll see y'all next time. Bye now.